is outside the center of the wheels, tremendous side pressure is developed on the bottoms of the tires, creating a centrifugal force that tends to swing the center of gravity in front of the wheels. Here's our plane, and this is the direction of motion coming from outside the wheels, or a side force. Once the side pressure is exerted, the center of gravity takes over and pulls the plane out of control. There are various side forces that can cause an airplane to ground loop. One of the most common and most easily recognizable is a crosswind. In this illustration, the wind is striking the plane at a 90-degree angle. The largest horizontal surface area is from the main wheels back. The crosswind striking this large surface area tends to drive the tail downwind. This force, plus the forward momentum of the airplane, tends to push the plane sideways, putting tremendous strain on the tires. See that tire? It's buckling under a 90-degree crosswind of only 6 to 8 miles per hour. This pressure against the tire is driving the downwind wing towards the ground, exposing more surface area to the wind and setting up a horizontal component of lift that further aggravates the ground loop condition. With all these forces at work, even Aladdin and his lamp couldn't keep the plane under control. Here is a landing strip with a lateral slant. This condition, by reproducing the same forces that were exerted in a crosswind landing, will also cause a ground loop. The bias creates side forces against the tires. The downhill wing is down, inducing a horizontal component of lift. The center of gravity sets up a centrifugal force which swings the tail downhill, the nose uphill, and the plane into a ground loop. Another set of circumstances that will impel a plane to ground loop is oleo struts of unequal length. Sometimes when a plane is landed with unusual violence, the oleo struts after the recoil will